Yes, good morning, everyone.
Good morning, sir.
The topic called block diagram of OPAMP. So here, the block diagram of operational amplifier consists of total 4 stages are there. In that, the first stage is input stage. The first stage is input stage with 2 inputs, inverting input and non-inverting input. The output produced by the first stage, that is input stage, is given as one of the input to the intermediate stage. And the output produced by the intermediate stage can be applied as input to the buffer or level shifter circuit. Buffer or level shifter stage. And the output which is produced by this buffer or level shifter stage will be given as input to the output stage. And finally, at the output of this output stage, we are going to get the required output. See here, let us see its operation. Input stage. In input stage, we use dual input. Here in this, we use dual input balanced output differential amplifier. In input stage, we use dual input balanced output differential OPAMP. The purpose of dual in balanced output differential amplifier is it rejects the external noise. It rejects the noise in the input signal. In input stage, we use the differential amplifier of type dual input balanced output. The purpose of this dual input and balanced output operational amplifier is it is used to reject the noise, internal noise of the input signal. In addition with that, this dual in balanced output differential amplifier, it also maintains high input impedance, that is high input resistance, as well as high closed loop gain. The purpose of using dual in balanced out operational differential amplifier in input stage is it is used to reject the noise in the input signal, and it is used to maintain the high input impedance as well as high closed loop gain of OPAMP. And the output which is, and we will see the internal operation later. First, overall, let us discuss. The output produced by this input stage will be given as input to the intermediate stage. In intermediate stage, we use a differential amplifier of type dual input unbalanced output. Dual input unbalanced output differential amplifier we use. The purpose of using this dual in unbalanced output is in order to provide the high voltage gain as well as it is used to produce high voltage gain. The main purpose of using dual input unbalanced output differential amplifier in intermediate stage is it is used to maintain the high voltage gain. The gain which is produced in the input stage is, say for example, X amount, then This intermediate stage is used to boost the gain of the overall op-amp. This intermediate stage is used to boost means increase the overall voltage gain of the op-amp. And this dual in unbalanced output differential amplifier, it drives the output of input stage. It drives the input of, it drives the output of input stage or first stage. Next, whereas if you come to the buffer or level shifter circuit, buffer or level shifter stage, the main purpose of buffer or level shifter stage is it is used to, we can also call this as emitter follower circuit. This buffer or level shifter circuit is also called as emitter follower circuit. The main purpose of this emitter follower is in order to maintain the high input impedance and low output admittance or low output resistance. To maintain the high input impedance and low output resistance, and also to avoid the loading effect. To avoid loading effect. We are going to prove all these things to avoid loading effect. So that is the purpose of emitter follower, and moreover, the main important thing to use the emitter follower circuit in the third stage is, so this emitter follower level shifter circuit can make the DC level to 0. It can make the DC level to 0. Say for example, stage by stage, all cascaded here. Stage 1 output given to second stage, stage 2 output given to third stage output is given to fourth stage. Because of this cascading of stages, there is a variation in DC voltage level of the op-amp. If DC voltage level of the op-amp varies, it shows the impact on overall circuit performance. How that is, I am going to prove that. So this level shifter circuit is also used, main purpose, it is also used to maintain, or it makes the DC level to 0. And the output which is produced by this level shifter circuit is given as input to the output stage. In the output stage, we are going to use complementary symmetry push-pull amplifier. Here, we are going to use complementary symmetry push-pull amplifier. Push-pull amplifier. Right? What is the purpose of this push-pull amplifier? First one is it maintains constant Q points. To maintain the constant or stable Q points. Second thing is it maintains the high input impedance and low output resistance. Low output resistance. So these are the purpose of this block diagram, operation of block diagram. See once again, the block diagram of consists of total 4 stages. The first stage is input stage, second stage is intermediate stage, third stage is buffer or level shifter stage, and the fourth stage is output stage. Right? Input stage. In input stage, we are going to use a dual input buffer output differential op-amp. What is the purpose of the dual in buffer out, balanced out, dual in balanced out differential amplifier? What is the purpose of that amplifier? Is the main purpose is it is used to reject the noise which contains noise of the input signal. If there is, say we are applying the input signal at the input stage, if there is any noise added in the input stage of the input signal, then that noise can be eliminated with help of this dual input balanced output stage. And So it is used to increase and also it is used to 442 ఎవరమ్మ వాళ్ళు మైక్ బ్లాక్ చేయమని చెప్పండి వాళ్ళని ఆఫ్ చేయమనండి మ్యూట్ చేయమనండి ఎవరండి వాళ్ళు గుల్వార్ 442 ఎవరు వాళ్ళు అభిషేక్ ఎవరు వాళ్ళు పలు రాలగొట్టు ఎవరు వాళ్ళు వేసుకోవాలి
హారిక సార్
చెప్పు వాళ్ళకి టెక్స్ట్ అమ్మాయికి
మ్యూటెడ్ సార్ మ్యూట్ చేస్తుంది
And also the purpose of dual input balanced output differential amplifier is it is used to increase the input impedance as well as closed loop gain of OPAMP. And the output which is produced at the input stage of first stage which is applied as the input to the second stage. Second stage is the intermediate stage. It consists of internally dual input unbalanced output differential amplifier is there. The purpose of the circuit is it is used to maintain the high voltage gain as well as it can also drive the output of first stage, right? And the output of the second stage will be applied as input to the third stage. In third stage, we use the circuit called buffer. Transistor acts as a buffer here. Buffer circuit. So the purpose of buffer is, we can also call this buffer as a level shifter. What level? A level shift chestundante? It shifts the DC level of the circuit. DC level of the circuit, right? So this level shifter, we can also call it as emitter follower circuit. Emitter follower circuit. So because of these cascading stages, because of this cascading అంటే if you apply the output of first stage as the input to the second stage, output of second stage as the input to the third stage, like this connection, this is called cascading. Because of this cascading connections, there is a change in the DC voltage level. If DC voltage level changes, it shows the high effect on the circuit. ఎలా improve చేస్తానండి. So in order to maintain the DC level, we need emitter follower circuit or level shifter circuit or buffer circuit. One thing. And the second purpose is it is used to increase the input impedance, that is input resistance, and reduces the output resistance, and as well as it is used to avoid the loading effect. So output produced by the buffer stage will be applied as an input to the output stage. In the output stage, especially we use complementary symmetry push-pull amplifier. Complementary symmetry push-pull amplifier. The purpose of complementary symmetry push-pull amplifier is to maintain the constant operating point or Q point, and as well as high input impedance and low output resistance. High input resistance and low output resistance. To maintain all these things, we need a complementary symmetry push-pull amplifier, right? So this is the overview of the block diagram of OPAMP. Now let us see one by one block. Each block, let us discuss about each block internally by taking its internal circuit. Let us discuss. Okay? Next class onwards, I'll try to reduce the resolution of my camera. Okay? And ఇంకొకటి ఏంటంటే they are explaining